Ed Schofield, who today will be talking about better data frames. Everyone, big hand for Ed. Thanks.
Hi. Thanks for coming. So the pictures here, oh, there's nothing showing yet. Can we have, there we are, beautiful. All right, so we have a panda, we have a polar bear, and we have an ibis. These are three of the data frame libraries I'll be talking about in this session. Thanks for coming. So now pandas is sort of a heavyweight data frame library in Python. It's been around for about 10, 15 years. And at the moment, there's a kind of proliferation of upstart packages which have different ideas that they've been exploring. And I'd like to help you know what these are and make sense of these, so you know which package to choose for your next project, or if you're a library maintainer, that you know how you can support different kinds of data frames in inputs to your functions, for example. So here's the outline of this talk. So I'd like to just go over the history of data frames briefly to help you understand some design limitations that Pandas has, and then describe some of the alternatives and efforts at interoperability. And then a few minutes, if there's time, with some more philosophical thoughts on the nature of the kind of creative process, this creative destruction process in open source, and some recommendations about which packages to use and which techniques to use for different tasks. And if we have time at the end, I'd welcome questions as well. So my name's Ed Schofield. I have a background in mathematics and computer science, and I did a PhD in language models before most people knew what they were. In fact, while procrastinating writing up my PhD, I got involved in development with SciPy, and at the time, actually, the tools were quite kind of primitive and broken. So NumPy and SciPy needed to be developed to be useful for machine learning research at the time. And anyway, Matplotlib didn't exist, and so that eventually came around 2005 or so. So I founded Python Charmers after that. It's a training business, and we're based in Melbourne and Singapore. And we've given about 700 training courses over the time, about 500 in Australia. Most of them are kind of live with hands-on coding. I was involved in the Python Future project when I was concerned that the Python 3 migration was happening too slowly. So it looked for a time like Python 3 might be dead on arrival and it might become a Perl 6 situation. And thankfully, the community rallied to do a big push to make this migration possible. But it looked quite kind of close for a while. So I got involved in the Python Future project to sort of assist with that effort. For fun, at the moment, I'm doing a set of courses through Stanford in AI, particularly in reinforcement learning, which I'm finding really, really fun. Something I haven't really explored, but it's a brilliant field. So anyway, that's what I'm doing at the moment for fun. So first of all, what is a data frame? Most of you probably use them. Can I have a show of hands, please, actually? Who uses data frames? Most of you, okay. So it's not a vector, it's not a matrix, it's not a multi-dimensional array. It's a bit like a matrix in a sense, but you've got heterogeneously typed columns. So how is that different from just a table? I'll come back to that in a moment. But this is another view of a data frame. You've got a column index or sort of column names, and you've got multiple series of data, and this is the terminology used by both pandas and polars. Notice there's no index in general. That's a pandas concept, but most other data frame libraries don't have the concept of a row index. And so how are these different from tables in SQL databases or tables in spreadsheets? Well, I suppose terminology-wise, tables in relational databases have row relationships, and traditionally relational databases store data row-wise. So operations, analytic operations are not optimized as they are in the new breed of columnar databases, OLAP databases like DuckDB, and dataframe libraries. Okay, so dataframe libraries store data column-wise, and this allows fast vectorized operations. Traditionally also, there's been this sort of terminology that a dataframe is something that lives in memory. It's not always true now, and the lines are blurring, but traditionally you would do a kind of import of data, suck in lots of data until you've got it all in RAM, okay, which of course naturally puts a limit on the size of data sets you can work with. All right, but that's changing these days. So dataframes really support kind of janitorial kinds of tasks which are necessary before you put data into a machine learning model, for example, or do a regression or something like that. Dataframes are kind of have features for cleaning up data, for aggregating data with time series and things like that. Okay. Here's a post from Big Data Borat 11 years ago. In data science, 80% of time spent prepare data, 20% of time spent complain about need for prepare data. So he understood that very early. All right, so now here's a brief sort of set of words about the design of pandas and where it's come from. So in the beginning, we had this, but then a few billion years passed, and we had the 1970s. And so in the 70s, the S language came out of Bell Labs, and SQL was sort of developed and started to be standardized, and the first spreadsheet package, VisiCalc, became widespread. In the 80s, we had data.frame as an object in the S language. Python came out in 1983. R came out later that decade. And in the 90s, there were these packages, numeric and numarray, which made use of Python's great C API to extend Python, to make it useful for scientific computing in particular and engineering computing, some of the early applications of it. The MySQL database also came out in the 1990s, just for historical context, as part of the LAMP stack. Postgres was in 2000. It wasn't until 2005 that NumPy came out in its first release in its current form, which is a kind of amalgam of those two earlier array packages, numeric and numarray. And SciPy came out at around the same time. Matplotlib a year or so later. When I started working on SciPy, it contained 3 separate plotting libraries, and all of them were broken. So I was very happy to have Matplotlib to create some plots in my thesis. Pandas, I think development started around 2008, which is pretty early. So this is sort of interesting, this historical note. So it predates the kind of innovations in R on other kinds of data frames. It predates Spark and big data tools like BigQuery and so on. So the first of the kind of now tidyverse packages in R came out in 2011, and dplyr and tidyr came later, and the tidyverse was sort of formalized more in 2016, and that's also when development started on the Apache Arrow project. Now, this was really an initiative of Wes McKinney, who's the original author of Pandas, and Hadley Wickham from the R community. So Wes McKinney wrote a blog post in about 2013 or so, I think, perhaps a little bit later, 2015, called 10 Things I Hate About Pandas. And he gave a talk at the New York City Python meetup or something like that about that. And so he was aware of these design limitations from the beginning, but But by then, Pandas adoption was really growing. And I think we've got Pandas to thank for the fact that Python is where it is today as a tool for manipulating data. So R was very much loved by users and still is. There are R users out there who say, no, you'll take R out of my cold, dead hands. You've got to claw it out. And the tidyverse is a wonderful kind of ecosystem of packages. But it's quite possible that without Pandas, Python wouldn't have had a big role to play in many different kinds of subfields of data analytics and data science, or at least not as big a role as it does today. So Pandas builds upon NumPy as a foundation, and that also gives it a couple of limitations. NumPy, I want to, sorry, an old version of this slide, but NumPy provides a multi-dimensional array object, but no support for masked. Well, it supports a masked array, but it doesn't support sort of missing data natively for a range of data types. And the masked array feature never really took off. And it provides record arrays and structured arrays. Those aren't really a substitute for data frames in Pandas. So Pandas built upon NumPy and provided that kind of tabular analytics functionality. Okay, so there's a data frame in Pandas. It's like the diagram you saw before, but there's this row index down the side. Now, there are people who use the row index to its advantage, and you can get better performance by making use of it. But a lot of people just don't know what to do with it and just find it an annoyance and try to drop it or reset it or something like that. But it's an interesting design decision because it does complicate learning Pandas. But yeah, I think a lot of the sort of new breed of data frame libraries don't use a row index. Many SQL databases also traditionally haven't returned data in a consistent order, and unless you explicitly call order by as a clause. All right, so I'd like to say again, sort of 3 cheers for Pandas. It's done us well. It's used by millions and millions of people, and what it does well. So it does in-memory analytics. It's expressive. It's got an enormous API, which is it means you can do a lot with it, but it also makes it harder to maintain and things like that. Its focus isn't there, and it's got a lot of open bugs, partly because there are a few maintainers putting in a Herculean effort to kind of support millions of users who are all complaining that my sort of such and such doesn't work. So it's played a very important role in the Python data ecosystem. Now, Pandas 2 was released last year, and there are a couple of architectural improvements. It supports optional backing of all of the columns in a data frame with the Arrow sort of a package, with the Arrow standard that this supports. And this provides the ability to have missing data on all data types. It also provides better string handling than NumPy has traditionally provided, but NumPy 2.0 does change that, but NumPy 2.0 doesn't have a good answer about missing data still. So there's this limitation there. There are some other limitations as well about sort of memory usage, in particular that limit the scale you can of data you can work with Pandas. So there's assumption that you pull in all your data into memory, for example. But there are some new copy on write features which can assist a little bit. But the Pandas 3.0 release is still sort of in an early design phase, and the design is not decided yet. There's been some kind of back and forth about whether Arrow types should be supported by default. And initially that was going to be the case, and then someone said, hey, wait, this brings in another 500 megabytes of dependencies. What's going on here? It's a very heavyweight dependency, it turns out. So it's unclear what the future of the project is, and I'm thinking it will probably not go away anytime soon, but it's going to become continually less relevant in relation to the other data frame libraries. So I think sort of Marie Kondo says sort of say, bless something, and then they say, if you don't no longer need it, bless it, and then throw it in the bin. So this is perhaps what we should be doing here. And I don't think this would offend Wes McKinney, who's very aware of its design limitations and has been actively kind of contributing the last sort of, the last 10 years of his career towards improving this current situation. So here are some alternatives. Now, this is a set of GitHub stars. Look at the blue line, that's Polars. The green line is DuckDB. The red line is Pandas. Okay, so king of the castle right now, but its acceleration, it sort of, seems to be smaller. It's a second moment. And we've got, various other kind of little tools there. But in particular, the blue and green lines are interesting. So one thing that's not really listed, which is super important, is this. So this was, as I mentioned, the initiative between Wes McKinney and Hadley Wickham to define a cross-language standard for how data can be accessed in memory, which supports nullability of all data types and efficient zero-copy reads and writes. So this is critical, and this is better than NumPy in a way. NumPy is Python-specific. Arrow is cross-language, so it's really very powerful. And DuckDB is based on Arrow. Polars is based on Arrow. A lot of the current breed of new data frame libraries are based on this standard. Okay, so this is sort of the invisible stitching behind the scenes that makes this all work. So if it looks like there's a complicated ecosystem of new ways of doing things with data frames, in a way that most of them are linked together by this. Okay, so it's not as incoherent as it seems. Okay, so Arrow solves these kinds of problems that Pandas is tightly coupled with NumPy, with its limitations. Pandas also, Arrow also supports other languages. There's this Nano Arrow package, for example, and a variety of other C libraries you can use and link in with various languages. So Arrow does say something about what you can do to process larger than memory data sets. Pandas has never had a good answer to this story. For example, you can't use sort of memory, like disk-backed sort of arrays in memory, and what am I talking about? Okay, mental blank there. But it won't support sort of this transparent mapping of memory mapped files. That's what I'm trying to say. Yeah. Okay, so Pandas creates lots of intermediate objects in memory, which is quite wasteful of memory. So this creates an intermediate series, and then filters on that, which creates an intermediate data frame, and so Arrow can help with that. And I mentioned memory mapping. Okay, so Polars is a very interesting library. As I mentioned, it's based on Arrow. It does have a limitation, fundamental kind of limitation, that it is designed at the moment anyway for local in-process data processing. So it's not designed to run across a cluster. Right? It's not an alternative to Apache Spark or PySpark. But DuckDB is also targeting this niche. They're very, very closely related projects. So it's fast, neck and neck with DuckDB in terms of benchmarks. It's written in Rust and has kind of documentation and interfaces in Python and Rust. And the API is quite nice. It's not as warty or clunky as the Pandas API. It's a bit more verbose. but people like it, just like people like the dplyr API from R. So DuckDB, you'll notice some similarities. It's also based on Arrow. It's also for local in-process data processing. It does, however, have good support for spilling data to disk to some degree. Okay, you probably don't want to go about more than 10 times RAM, so not more than 100 times RAM, but DuckDB and Polars will let you handle data sets of potentially up to 100 gigabytes or a terabyte if you've got lots and lots of RAM, but you can't really push them beyond that very well. DuckDB has interfaces in most languages, which is nice. So some of you would have gone to the DuckDB talk. You can think of it as like SQLite, but for analytical queries. But the Python API is verbose at the moment, and it hasn't really had the same attention as the underlying DuckDB library. So I wouldn't recommend the Python API for DuckDB at this stage. There was this original plan to build out a Dataframe API like Pandas or Polars or something with a DuckDB backend, which is not a bad plan, but now others are doing it better. So they're focusing on where they can contribute, which is the basic library. So here's Ibis. It was started by Wes McKinney around the same time as the Apache Arrow project. And what Ibis lets you do is to scale from local to cloud with the same API, which is a really interesting kind of value proposition, I'd say. So originally, was implemented apparently as an interface for Impala, but now it supports about 20 different backends, including DuckDB and Polars. It did support Pandas, but that's being removed now because Pandas is so different from all of the other engines. So it was like using 40 or 50% of the entire code base, and it was not worth it since it was slower anyway. It's still, but this will quite happily read data from Pandas dataframes in memory. That's not a problem, but it just no longer pushes data out to Pandas as an execution engine. So I think of this as being like SQL Alchemy for analytical queries. I haven't seen that kind of epithet used, but that would be a good tagline for the project. SQL Alchemy is brilliant, of course. We don't need to write custom code for each database and introduce a degree of portability and so on. And that's what this aims to do too, this project. Okay? And it's actively developed and growing. It doesn't have the same traction or kind of hoo-ha as Polars, but it probably deserves more than it's getting. So here's a quote from the site, a blog post from the Ibis project. If you're considering Polars for new code, give Ibis a try with a DuckDB backend. You'll get better performance than Polars on some workloads with a broader cross-backend API that helps you scale from development to production. Okay, so you can use the same API for processing your data on your local machine as for processing data through BigQuery or ClickHouse or something like that. So there's the current list of backends from the Ibis website that Ibis supports. So it's really interesting. You'll notice that there's one dataframe library, Polars, and the other are all SQL engines. So it does a good job of converting SQL. These days, it's making use of a package called SQL glot to do that, which is something it's probably worth watching. So you can just translate between SQL dialects there. Now, there's this deferred execution model that Ibis offers. You can kind of connect to some remote database, whatever the store is. You perform some SQL query, you get your results back, but it feels like a local database. And that's especially important when the connection between your local machine and the cloud is weak. It's like some slow connection. Okay, so you've got all this data up there, and you've got a fast computer, but this tiny little wire connecting them. So I saw this was an important kind of news announcement recently. So until we have a new carrier pigeon-based network that's competitive, it's a good idea to do the processing on the remote instance instead of pulling all the data over the wire. Just a couple of others. This is a GPU library. It's limited by VRAM. It's NVIDIA cards only, so it won't run on your Mac. But it now has nice integrations with Koalas and Pandas. Modin and Dask dataframes are both efforts to scale out Pandas dataframes to a cluster. So they try to mimic the Pandas API, which is good for compatibility, but it has its warts and so on as well. Narwhals is worth using if you want cross dataframe compatibility, if you're writing a library that needs to accept different dataframes. Okay? You can use it, for example, like this. Okay? So this would be a function that accepts a variety of different data frames and does what's necessary, preferably without memory copies to support those. Now there are, just a note on benchmarks, Polars and DuckDB are often neck and neck in performance, but they're both a kind of big step up from these other kinds of libraries, and Pandas and dplyr are sort of in the dust. I'm not sure what Arrow's doing there. I'm not sure, because these are based on Arrow, so that's a bit surprising. I'm not quite sure what that's about. So Arrow is a very, very well-designed specification. Here's a quote from Will Ide from an interesting blog post about the Arrow C data interface. So one, you'll want to look at this for Napari and anyone else who wants to support zero-copy memory access from data frames. The mechanism is this Arrow C stream, the C data interface. It's becoming the standard mechanism to support Arrow-based data, with a lot of kind of benefits there. So if widespread, this would support zero-copy operations without requiring PyArrow, which, as I mentioned, is a big dependency. So, so this is the goal of data frame agnosticism. Currently, there's an effort underway toward removing pandas from a whole bunch of different projects as a dependency, which is quite interesting. But still accepting the data frames, of course, just no longer requiring it there. So I will just skip to the end as I'm out of time. If you're interested, please approach me. Sorry there, and please, could you go to that there and that there. So I'd be happy to kind of give you a live demo. I have prepared a live demo too. Of alternative data frame libraries, how you can use them in practice, and what the experience is there. So please email me, and I'd be happy to chat to you more. And please come and find me afterwards. I'll be hanging out probably outside. All right, so thank you very much.
Thank you very much, Ed, for that talk. I would like to present you with the Pycon.
Thank you.
I think we've got time for one question.
Okay.
Does anyone have a question for Ed? Yep, we've got one at the back.
Thanks, Ed. That was brilliant. I come from Earth Science Community, and there we use Xarray, NetCDF, HDF55. How do you see the relationship between that and what you presented?
Yeah. These, I'd say data frame libraries are not really focusing on that use case. There's a little bit of overlap, but I don't yet see any efforts underway to, for example, generalize Xarray to use Polar's data frames under the hood or something like that. So I don't see any overlap at the moment. There will naturally be improvements available in performance, for example, with working with large data sets by virtue of the Apache Arrow format, if these libraries start to use that. So that might be the first kind of point of entry for those libraries to support, for example, missing data at a deeper level than NumPy does.
Well,
thank you.
Everyone, could you please join me in thanking Ed once more?
That's all right. Okay.